Hi, America here, back with another video, and today I have something quite special for you. As you could notice, I didn't upload for a while. It was like 3 months since my last actual video. The introductory video doesn't really count, obviously. And I've been busy doing something you could say a mad lad would do. And I actually said that I'm doing something very specific in my post. So if you follow my post, then you already know what this video is about, or you actually read the title of this video. And they indeed called me a mad lad. Cheers, Mr. Durarara 11. But I did it anyway. I made my programming language entirely in Blueprints. And why would I do such a thing? And how long did it take me? Well, it took me actually 2 weeks to make it, which is surprisingly longer than it took to make JavaScript. But for my defense, I didn't know anything about making a language before that. So in that 2 weeks, I had to kind of learn how to do it. And through trial and error, kind of make it all work. And it was hard as fuck. I'll tell you that. Do I recommend it? I don't know. It's pain. It's pain to do this. I don't think it would be easier in C++, but now that I actually made this in Blueprints, I have some base I can use to port it to C++. Of course, for the performance reasons, and the Blueprints version is super slow, but it kinda works. And why did I do it? I did it because for a long time I wanted to make my own programming language, so that's first. But the second reason is that I'm making a game. I'm making a game that I will link you in the description when it is announced, so not right now, but probably in a week or so. And I will, of course, make more videos about that game when it is announced and what could you expect from that game. And what I can tell you right now is that in that game, you will be able to make your own programs and maybe possibly hack something and program other devices with your own programs, right? So you can use a PC, write a program, upload it to a device, make it run, and do all sorts of things you want. So that was the goal. And what was the goal for the language itself? Like how it's supposed to work, what it's supposed to be. Well, my assumptions were that it's supposed to be a fairly simple language, but it should have all the necessary things that programming language should have. And I added my unique twists to that. So there are things in my language that you won't see in other languages. Maybe they didn't add it for good reasons, but oh well, it works for me, so I did it anyway. So yeah, let's kind of dig into that language and see what features it has. So let's start from something simple. Let me just take my VS Code, because I write it in VS Code. I have my own text editor, kind of IDE in my own game, but here I'm just using VS Code because I'm just importing the text by itself. And maybe let's start from something super simple. So variable declaration. In all languages, well, the variables are pretty fundamental. So yeah, we have variables in my language, obviously, and we can assign something to them. So x equals 5 means this is an identifier. This is a binary operation between those two tokens, and this is a literal, integer literal. We could do something that Rust does, so we can assign a type to that variable. So we have x of type integer, but if we don't do this, then the identifier will check what type does this token have, and it will just auto assign the type to that identifier. So x automatically becomes an integer. And when we run this, my, of course, system will process it, import, and kind of flex, parse, whatever, and input the result. So we have 5, lovely. And let's move on. We have some more things that we can do in my language, obviously. We can do addition, and we can do multiplication. And it obviously respects the, let's say, the order of operation. I mean, not let's say, it's just order of operations. So this should multiply first. So 25 plus 5 should be 30. And it is 30. Lovely. Let's move on. What can we do else? Well, let's maybe move on to things that are not as usual. So things that are different in my language versus other languages. In C++, we have bitwise operators. And in my language, there are no bitwise operators because I decided that bitwise operations are pretty low level and won't be useful in my language, in my game. So I just decided to kind of omit them and use them for a different purpose. So an example of a bitwise operator in C++ would be the bitwise AND. And bitwise AND obviously kind of, strips that 5 into bits. So 5 would be right or wrong? Wait, 1, 2, 4, 5. Should be 5. And yeah, we have 2 5s. So 101, 101. And yeah, it just prints 101 because this is the end, bitwise AND. And if that was 1, then this would be still 101 because it has to match. 0 and 1 is not the same. So if that was bitwise OR, then that would be 1, but it bitwise AND, that is 0. So that's bitwise operators 101 for you. And in my language, I decided I don't need that, so I just use this as AND. And what does AND do? Well, it appends. So if we do 5 and 5, then it's 55 because because we have 2 5s, obviously. And we can do this between types because at the end, every token in my language is a string. So we could just as well do index and 5 and just do this, and it will be 5. I mean index 5, right? So this is one of the changes. Second thing, maybe let's go to arrays. How do we kind of make arrays in my language? In other languages, you could kind of like do x and length of the array and kind of do this and 5 5 5, and this will add an array of 5s to your array with length 5, which of course will be just 3 elements in 5 elements length array. In my language, arrays are always dynamic, so you could say they are vectors and you assign them as this. So 5, and instead of comma, my separator is that little wall, which I like more than the comma because it kind of feels like a separator, and the comma doesn't feel as separatey as this wall. Okay, vertical line, I guess it's called. So we could do, maybe let's do just 1 2 3, and this is how you declare an array in my language. And what if you wanted to kind of get something out of that array? Well, very good question, because I have a special operator for that, for getting something out of an array. And this is add. So if we wanted to take a first index, or index 1, because first index is index 0, obviously, then we write x at 1. What's at first index of that identifier? And it's going to be 2. Yeah. And the fun thing is that we can sort of expand it for other types of variables. So we could have hello. And if we do hello and we do x at 1, it will return e, because e is the first index of that string. And you can say, oh, but yeah, C++ has it, of course. We could just do x1 in C++ and it will return that that first, not first, just index 1. But you can't do this with numbers. So let's say we have this little number, and we could also take the first index 1 of that a number, and it will be 2. Lovely. So little fun things you can do with my language. And what's next? My language, of course, supports references and dereferences. So if we, let's say, have x equals to 5 and we wanted to do y equals to x, then by default that y would become 5. But if we wanted that y to point to x, then we would do this, which is also kind of, you know, I'm using it for appending, but this is binary, and this is what we're doing right now is unary operation, and it will be treated as a reference. And then when we want to dereference the variable, we just do this. And this is different from C++, because in C++ you have this, of course. This means the reference, and in my language I decided that this sign, this dollar sign, is looking kind of appropriate for this task, because the dollar is kind of that S which is strike down, which, I mean, by intuition, for me, striking something down is kind of similar as dereferencing. So I decided to use that for my language. So what's next? Well, we have some very nice additions. We have something like this. And what do you think this does? Well, in my language, I decided that input and output operations should be very simple. Like in C++, if we wanted to print something out to the console, then we would have to do std cout, then print something like hello, and then do this, and then end line, of course, with the namespace, and then this, and it's pretty long. And in my language, we just do this. This is like, if we do hello, then this is exactly the same as this in C++. So very, very lovely. Let's just make a kind of blank return so we can see this works. Lovely, hello. And if we want more, then we just do more. And we have 3 hellos. Lovely. And this, of course, goes into the input as well. So if we had some kind of variable, or we don't even need to declare it, because the operator, we declare it anyway, if it's not present, we could do this and just x. And whatever we input here will be saved to that identifier. And then we can just print it. So let's use our append operator to kind of make it a little more verbose. Let's ask the user for his name. So, what's your name? And then the user inputs his name, and then we can say your name is append x. Of course, this is an identifier. And we have this, what's your name? The program holds, and then we can type, my name is Mr. Koshi. Send. Your name is Mr. Koshi, lovely. Works just as intended. And yeah, I think this is very, very cool, very nice. Of course, you could say, okay, but you kind of always print with an end line. So this might be sort of an issue, but it's not entirely an issue because you can always make a string builder and kind of, you know, like init with whatever space and then just string builder equals string builder and whatever you want to add, and then just print that string builder in here, right? Or rather here. So it's not entirely an issue. You could work around this. I suppose I could do something more about it, but whatever. And what else? What do we have in my language? Well, if we do x equals 5, I didn't forget this. We also have incrementators, so plus plus, and x minus minus. So this still works in my language. I'm still working on adding this. Shouldn't be too hard, but for now, just do this. It's just syntax sugar anyway. What's next? Well, every programming language needs some kind of control structures. So you can't really have a program that is Turing complete if you don't have branches. So my language also has branches. So let's say we have some kind of a simple branch. This is if, and we can just check if x equals to whatever we want. So 1. And if that is equal to 1, then we can, I guess, print something. And let's print whatever. And if it's not 1, then it just goes further. So if that ends, then let's just print end or return end if we if that x is equals to 1, then we should see whatever. And after every control structure, which is different to other programming languages like C++, we also have to add semicolon after control structures, because this is kind of an expression, and we have to end expression with that semicolon. If we forget that semicolon and add another thing after that, then it will kind of be interpreted as two separate expressions, and we can't have two separate expressions right after the other. We have to return a single expression. Yeah, let's see if that works. And so x was not 1 indeed, but let's change x to 1. Whatever. Works just as intended. And I also, in my language, decided to kind of delete bools because I decided that bools are just syntax sugar for integers. Yeah, in my language, we just have 0 or 1. So if 1, then yes. And if 0, then false. Just simple as that. And this simplifies a lot of calculations. I don't have to make new keywords and kind of interpret those keywords for what will be integer anyway. So just do this, right? And let's move on. Another control structure we have is, let's say, while. That while could also take that x, let's say 3, and let's add that to while. And that while will print while 3 is not 0. But of course it will be always not 0, so we have to add some kind of decrementer. So let's add that. Let's add this, and this should print 3 times, or 2, I guess. 3. Worked perfectly. Another control structure is another loop, so 4. And that 4 is taking, we don't actually declare any variables inside of that argument. We just say how many iterations we want. So 4, 9. And this will print whatever 9 times. Lovely. I think that's great. I mean, you could disagree with me and just say, oh, but you can't do your custom conditions. You don't have iterator. You don't have this and that. Shut the fuck up, okay? This is super simple and I love it for my language. And if you need an iterator, well, surprise for you, we have an iterator. It's built into the loop. I kind of stole that idea from Jay. And you could do this. What's the current index? Index is equals to it. And iterator is the, the value of iteration. So 1, 2, 3, lovely. So yeah, that's loops. This iterator is built into every control structure, so you have that in the while loop, you have that in if for some reason, if you wanted to access that. Maybe you are running if for, I don't know, 2 times and you need it, and I don't know why would you, but it's in for and it's while and it's working lovely. So let's move on. Apart from control structures, we need some kind of normal structures, because if we are making some kind of bigger programs, we need structures. So we can have structures in my language as well. So let's say we have this struct. This is a vector2d, which has 2 values, and we can kind of print those values. So let's say, also, this is kind of different from other languages, is that my struct is always initialized. So we can easily take default values from the vector. We can, of course, make new vectors, like vector1, let's say, and it's equal to vector2d. And it's kind of making a copy of that vector and putting it into v1. And then we can change v1 to, let's say, v1.x equals 9, whatever. We do a field access, and we can change it to v1, but we can also just take default values from vector2d. So we could just as well do this, vec2d, and kind of print it. And we can assign those default values to other identifiers that copies that struct. So that's lovely. And what's next? Well, we can of course do other programs that are not kind of defined, because one thing you need to know is that every kind of structure is a program. This file is a program. And everything in that program, that struct is a program, the if, while, for is also a program, and they are just special types of programs. So the structs don't take any parameters, any arguments, and they are initialized immediately. The for example, so you could say we have that loop is declared and run immediately, and it takes arguments. And we could declare our own sort of programs. We can do this with fn. I kind of stole that from Rust, obviously, and I probably should change the name to prog, because I called this a program, not a function, but it is what it is for now. And fn, let's do integer, because we need a return value. And let's do sum, or other, could also be like that. And let's maybe remove the structure. The other will take A of type integer, separator B type integer, and then we define the body, and the body will just return A plus B. Let's don't forget semicolons, and then we can just run that other with arguments. 10, 10. What is this? 20. Lovely. So you could do a lot with that. In addition to that, we of course have comments that you could see for the whole presentation at the top. So you could add those comments whenever, wherever you want, and it will just be ignored. I don't have multi-line comments yet, but I think that's kind of less prioritized. It has less significance. so just single line comments for now. And yeah, my language also has multiple operations and stuff you didn't see, and stuff that's different from C++. Yeah, like we could do 5, and instead of making a bitwise operators, we know that my language does not have bitwise operators. This will just make a power. So 5 to the power of 5 is of course this number. And I hope you enjoyed my little presentation of my new language that you can program in my new game that I will announce later, maybe in a week or two. And if you want, I can show you how I did this. I will kind of archive this project probably and just, you know, write it in C++ and then use the C++ version, and I just won't touch this and just update the C++ version. But this could be a very nice education project. And if you want, I can kind of tell you of my journey or of how I got to that point of a working programming language. And it was super hard, so I don't know how well I will be able to talk about it, but I sure can try. So if this is something you are interested in, then drop a comment, drop a like. Maybe I don't really want to dedicate my time to make 100 episodes video about making a programming language, but if that video reaches, I don't know, 100 likes, I'll make a tutorial, like full tutorial. If we reach 20, then I'll make some kind of general tutorial on how would you make a very, very simple language with addition, multiplication, some kind of return values, and that's it, without additional programs. Some sneak peek I could give you is that my language, or any language, kind of starts from a lexer. So you have that script that you wrote. So let's say this. And that lexer is kind of breaking everything down into tokens. So we have a lexer that does that. Then we need to pass it to a parser, and that parser is building basically something that is called AST, which is an abstract syntax tree. And that tree is the core of our program. And every kind of optimization that we want to do at compile time, not source, because my language is not really compiled, it's interpreted, but you still have to build that tree, that execution tree. And it's still unoptimized, it's still bad, but it works. And this is the core of the program. A little sneak peek at how this looks. Well, this is how my AST looks, and this is how my lexer looks. So every kind of class has a bit of code, and then tokens and nodes are also split into different classes, and each class has its own implementation. So it's kind of a lot to go through that, but yeah, this is what it takes to make a language. So I hope you enjoyed. I hope you learned something, and let's wait till half an hour because it's a round number, and see you next time. Bye bye.